Hello everyone and welcome to our new live webcast, Away from Prying Eyes, Running Code in Secure Hardware or Cloud Environments. Thank you for joining this new masterclass. With each episode, we provide new highlights, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. At WIBU-SYSTEMS, we empower software publishers and intelligent device manufacturers with cutting-edge technologies, new business models, and tailor-made consulting training. Let us help you upgrade, optimize, and automate your entire license lifecycle management so you can focus on monetizing your business at a higher level. My name is Daniela Previtali, Global Marketing Director at WIBU-SYSTEMS, and I'm delighted to have you here with us today. We are joined by Rüdiger Kügler, VP Sales and Security Expert, and Axel Engelmann, Architect Protection Technologies, both from the headquarters of WIBU-SYSTEMS. The means of protection need to be appropriate for the value and appeal of your software. With CodeMeter or AX Protector, you can safeguard your compiled applications against automatic hacking. IX Protector and Core API increase security even more. However, it's only with code moving that you reach optimal protection. By moving essential code into a CM dongle or a CM cloud container for execution, it keeps it far away from the prying eyes of would-be hackers. Some housekeeping we need to take care of before we start. For everyone who's joining us today, I want to remind you that we will be reserving some time at the end of the session for Q&A, and I'd like to invite you to submit any question you have in the live chat box. This session is being recorded, and a link to the replay will be posted directly to you in the next couple of days. And don't forget, stay with us throughout the live session for your chance to win 4 hours of free CodeMeter consultation from the most brilliant minds at our company. At the end of the webinar, a new tab in your browser with 3 simple quiz questions will show up. You should submit either one or multiple choices for each multiple answer question. We will draw the winner from among those who reply correctly and notify them at the time of the replay announcement. Please also note that the winner is excluded from all subsequent prize draws of 2022. Without further ado, I'll pass it over to Rüdiger. The floor is yours.
Yeah, thank you very much, Daniela, for this introduction, and also hello to all the listeners of the webinar today. And in the next 60 minutes, Axel and I will show you how to integrate CodeMeter to your software, give you an overview of the options, so how to use AX Protector, how to encrypt single functions, and of course how to use our latest and best of breed technology, code moving, so how to execute code in a dongle or execute code in a secure cloud environment away from the prying eyes of the hacker. In the beginning, the idea is to give you an overview about what does the hacker do. So it is we think it's very important to know how does a hacker try to reverse engineer software, to remove license checks and so on, to have an idea how we can do something in a way that it is hard for them or it's impossible for them to remove these checks and these anti-reverse engineering methods. And that's why a short introduction of Axel from the hackers side. What do hackers use? How do they do some hacking and so on? Axel.
Also hello from my side. I quickly cover the toolbox of a hacker. And let's first start with what type of an attack a hacker tries to get information from a program. There are 2 types, static and dynamic analysis. And the first one doesn't really execute your program. So it's more of a static perspective, and therefore tools which are used mainly disassemble or decompile the program for .NET. That would be the reflector with reflex heal or just decompile or ILDESN. So you simply open the program and look without executing any code inside the bits and pieces. And also a very prominent tool for this task is IDA Pro, which supports nearly all CPU architectures and has also a variety of decompilers inside it, and it's very powerful. On the other hand, you also have dynamic analysis methods, which try to gather information by executing the actual program. So most prominent tool would be Oli Debug. It's there for, I think, over 20 years. And it has also a few techniques inside it to disable anti-debugger checks and so on. So it's also very powerful. The most basic editing software would be an hex editor, where you can modify the bytes inside an executable or inside a library. And you can also gather strings from the hex presentation. So this is also kind of powerful, but you don't have any insight on any abstraction of the program. For Windows, native binaries, and also .NET assemblies, you also have the CFF Explorer, where you can gather meta information from a binary, which could give an attacker a first clue about how the binary is structured, etc. So for the variety of tasks, an attacker has a different tool in his toolbox to gather information, and we try to make them not applicable as much as possible with the upcoming techniques we provide.
Before we come to code moving, let's have some basic information about CodeMeter and how to integrate CodeMeter into your software. And let's start with how do you create a license with CodeMeter? The license in the CodeMeter universe consists of two numbers, of firm code and the product code. The firm code is something which is issued by WIBU-SYSTEMS. So we make sure that every user, every software developer, vendor who wants to use CodeMeter gets his own unique firm code to make sure that a license of vendor A is incompatible with vendor B, so that if vendor A creates a license, the user of vendor B cannot use this license for his software. The product code is something that you as software developer can define freely. It's an unsigned integer, so you have 4 billion potential product codes. And usually the product code is used to activate a single product, a single module, a single feature. So in my samples, I typically use the product code 201.000, and I use this for my software sample notepad. The 201.001 I use for additional feature, which is the change font feature. And the 201.002 I use for the hex view feature, so for next feature, and then the syntax highlighting and so on. So every feature gets its own individual product code. And if I put all the product codes in the license or in the dongle or in the CMAC license, the cloud container, then all features are activated. And if I put only the basic feature there, the software starts and I can do some basic stuff, but the extended features are of course not activated. And so you can activate or deactivate special features by adding or removing this product code. In one container, so in one dongle, Act license, cloud container, you can store up to 2,000 different product codes out of the 4 billion. So best practice is to have 100 to 500. So if you exceed the 500, the programming is or could become slow. Up to 100, programming and usage has no problem. So the 2,000 is the theoretical maximum. 100 to 500 is a very good best practice approach. And additionally, every product code, every product item, we call this a product item, which has a product code, can have different product item options, which define the licensing options. And I want to pick a few of them on the next slide. I don't want to go to any detail or into any detail. And the first mentionable is the license quantity. And with the license quantity, you can define how many applications or how many computers can use the software in parallel. So there are different options. You can say this is a local license, and the local license means it works only on the PC where the cloud container is connected, where the dongle is connected, where the Act license is bound to. Or you can say this is a network license, and then the user can set up a network server, a floating license server in the network, and he can use it on N computers at the same time. N is the license quantity that you set. for code moving, because code moving needs a lot of computing power of the container. That's why our recommendation is to use this only for local licenses. So important setting for code moving would be license quantity to one local and not to use this in a network, because this would not work from a performance perspective. There are some timing options. We had or discussed this in the last webinar about subscriptions. That's why I jump over them. We have some feature-based or some feature or versioning-based options like feature map and the maintenance period. So with maintenance period, you can give, or you can, if your user has a maintenance contract, which includes updates in next year, then you can set already the maintenance period until the end of next year. And every software that you release in this time will automatically be compatible to this license, and every software you release later after this date needs a new activation or a new change of the license. There are some other options like the module items where you can group features together. We had a very great webinar a couple of months ago about bundling or nesting. So if you want to have more information about this, go to this webinar. The unit counter for pay-per-use licenses. Then we have some features which are security features and which are connected to code moving. And maybe Axel can explain them better than I can do.
Yeah, let's first start with the maximum encryption rate. This is mainly used to prevent brute force attacks. And as the name says, encryption rate, it's something time-based. And the gist of it is that you can define how many executions are done per 30 seconds. So you can say like one execution per 30 seconds, and then the dongle checks that only one code moving call is done in this time frame. And this prevents attacks which can gather the gist of your algorithm by simply feeding it some input and analyzing the output. So we reduce the number of input-output pairs to a minimum, or you define how many input-output pairs can be done in this time frame. So this is very powerful against brute force attacks. And also we have the access password, and this has nothing to do with the CM access. This is coupled to the code moving call, and it's mainly to establish a secure channel between your application and the CM dongle or CM cloud container. And you also see later on that you have specified this access password identically in the protected application and in your license.
And the minimum runtime version is something which can be used to define runtime version of CodeMeter, so that you can say, with an older version of CodeMeter, my software should not start. I remember, and I'm here a couple of years already, that we had some big difference in 4.20 where we introduced the terminal server handling. And so if you have used the runtime version 3, the terminal server would have not been handled, and so you could start the software unlimited times on the terminal server. And so one of the recommendation at this time was to set it at least to 4.20 to make sure that the terminal server is correctly handled. In the meantime, the recommendation is something like 6. Something because of the universal verb code, or if you want to use code moving, then my recommendation would be 7.40, because here we have the code moving compatible for the dongle and for the CM cloud container. There are additional features like named user license bind to user linker time, which is made for short running applications, that a license will be allocated for a longer time, even if the application is already stopped. We have the license transfer. Also, we had a great webinar about the license transfer 2 years ago. And there are some other data options where you can read and write data with different read and write permissions, with a password, without a password, freely at runtime, with a programming sequence, which are not necessary for our basic protection and also for the protection using code moving. This is definitely my favorite slide, because this slide explains how CodeMeter works in detail. And if you have a CodeMeter container, then you program your license. Then you program something like firm code, product code. We learned 2 slides before. You can define the feature map in the maintenance period for versioning, for instance. And under the hood, CodeMeter system automatically creates a secret key, which we call the product item secret key, which is called PISC, product item secret key. And this is automatically created by the CodeMeter SDK tools, by License Central, by CMBox PGM. So when you create a license, you don't see the key, but it's automatically there. And this is the key that we use for the encryption, decryption, for code moving, and so on. So this is the secure anchor. And there is 1 key per product code. So that means that if you have 2 different software programs, and you have used two different product codes, then they have 2 different keys. And so with a license for one, it's not possible to decrypt the software of the other one. And this is the basic stuff of the security. So you don't need these data fields, you don't need these key fields that you can also use additionally. The product item secret key is automatically there when you program a license. Now let's take a look how the encryption works. So in your software, you define which firm code you want to use, which product code you want to use. So they address the entry in the dongle, in the container, in the ACT license. You define the feature code, which needs to be bit compatible or includes bits of the bit map. So the bit map could include additional bits, but all bits in the feature code needs to be included in the feature map as well. The release date should be something, needs to be something between maintenance period start and maintenance period end. And there are additional options like encryption code options. And when you want to perform an encryption, you send all this data, which is stored in the software, to the container. The container checks, do I have the correct firm code, do I have the correct product code? He addresses the product item secret key, and then he makes an internal key derivation to derive a key. And this key is used for an AES encryption, and so the plain text is transferred to the dongle. And then there's this AES encryption or decryption performed with the derived key. And the ciphertext is retrieved as the outcome of this operation. So this is the basic stuff that CodeMeter uses. And with this, we have keys for every feature. And now the idea is how to use these keys to have a good protection for these different features. And on the next slide, we show you how CodeMeter works in principle. Axel.
Yeah, code moving has kind of the same infrastructure. So we have a CM dongle and a CM cloud container. But you see, CM ACT license, TMR, and CM Cloud Light Container is not available for code moving. And this is because we can guarantee the same security as for CM dongle or CM Cloud Container, where an attacker doesn't have any access. Because for CM ACT, for example, an attacker could always analyze the PC memory, and this wouldn't be sufficient for our highest level of protection. So what do we have? As Rüdiger told you before, we have our product item, firm code, product code, feature map, all the same as you have seen before. What's new is the interpreter RAM. And this is a sandbox inside the CM dongle where we can execute safely arbitrary code. So what does it mean? The code moving program is a custom instruction set, which is encrypted machine code. And it's encrypted in the way you have seen before, with the protection parameter, where you specify firm code, product code, feature code, and so on. And you also have input for your algorithm. But this is optionally. You can also have a generator, for example, which only has output. So what's done? At first, the protection parameter are given to the container. Then we have our encrypted machine code, which is decrypted using the protection parameters. And then the decrypted machine code, together with the input, is put into the interpreter RAM. and there the execution starts of your specified algorithm. And after during the execution, there's potentially some data produced, and this is then transferred outside of the CM dongle. So you have like a black box which can execute arbitrary code, which you can feed with input data, and you get the output data. So let's see how all these techniques are integrated into our CodeMeter protection suite.
Before we come to the CodeMeter protection suite, I'd like to add something here to this slide. The code or the code which is moved to the dongle or which is moved to the cloud container is stored in the protected executable. It is not stored in the license itself. And yes, we know that this has some advantages and some disadvantages. And the disadvantage, of course, is we need the time to move the code into the dongle or to move the code into the cloud before we can execute it. And so from performance, it would be better to have it already fixed with the programming of the license. But on the other hand, this gives us more flexibility. And so if you say, I want to increase the protection of the software, you can have 10, 100, 1,000 different pieces that you want to move into the dongle. You move one to the dongle, execute it, remove it, and put the next part. So you are scalable in the level of the security. You can have more than one software program, software application on the same machine and using the same dongle, even with different product codes. You move the code from program 1, then you remove it, and you move code from program 2. And this also works in case of an update. So if you have an update where this feature functionality, which is moved to the dongle or to the cloud container, is updated, you don't need to change the license. You simply update your program and it's compatible to the already existing license. And that's why we have chosen the architecture of this dynamic code moving during runtime to give you more flexibility. But let's go to the CodeMeter protection suite. And CodeMeter protection suite includes our AX protector tools for automatic encryption of the executable and code moving and other functionalities. And what we see, we have our AX protector available for different platforms. We have it available for Windows, as Windows native executables, for macOS native executables, for Linux native executables. So native executables means something like written in C, C++, Delphi, Visual Basic, Fortran, something like this. Android, of course, also for native applications. We have some special version for VxWorks. We also can protect Java code running on Windows, Mac, Linux. In this case, it's not a native application, it's a Java application, a compiled class file. We can do this with .NET assemblies, and our latest members are the Python and JavaScript AX protector, with which we can also protect script languages like Python and JavaScript. So these are the available AX protector versions, and we have different features. And the basic feature is AX protector. This means we encrypt the whole executable, and then the executable is started, and then if the license is there, it works. If the license is not there, it doesn't work. The second thing is modular licensing, and in this case, you can define different features which can be treated separately. So for instance, in my sample, I had this sample notepad, basic feature, and I have the different product codes for change font, different product code for hex editor, different product code for syntax highlighting, and so on. And so this means with this modular licensing, you can assign parts of your code to different features. And then if the user has all features, you can use all the modules, all the functionality. And if I have only a few of them, I can use only the corresponding features, of course. IP protection is the option to use the AX protector without having a CodeMeter or without needing a CodeMeter license. So there are different use cases. One use case is you have a free software like a player software, but you have some intellectual property which you want to protect against reverse engineering. Then this IP protection is a good idea. Or you have a freemium software where say the software should start and I make my money or I create turnover by activating features later in the software, then of course it would be a combination of the modular licensing and of the IP protection for the basic shell around the software. And another use case is you want to use your own licensing system, homegrown licensing system, for instance, and you want to use the anti-reverse features of CodeMeter. In this case, you can use IP protection and have your own licensing scheme inside. And of course, we have code moving. And with code moving is the feature where you can have encrypted code in your executable that you deliver to your customer. And during runtime, the code is moved dynamically to the dongle, to the cloud container, and is executed there in a place where the hacker could not see, could not monitor, could not have not access to the executable code. The code moving feature is available for this native applications under Windows, macOS, Linux, and Android. VxWorks has a different architecture. That's why our AX Protector has a different architecture. That's why some of the features are not available there. And for Java, it's already available. For .NET, there is a beta version available, and I think it will be finally available with the next release. And Python and AX and JavaScript is already available. So you see, it doesn't matter which programming language you use, code moving is nearly available for all of this operating systems and for all of this programming languages. And even with .NET, the beta version is already there. And last but not least, we have file encryption, which is the option to encrypt some data or protect some data files, for instance, AI models or something like a configuration file, something like a recording file where you record some music, some video files, some audio files, and something like this. With our tools, we offer you a scalable approach. So you can use code moving, but of course you don't need to use code moving. It depends on the level of security you want to obtain. And as mentioned in the features of AX Protector, one option is use the AX Protector basic functionality, which means you take the executable and you encrypt the executable. And the executable then is encrypted with the key, which is corresponding to the key derived from the product item secret key. So every software with a different product code has a different key. And if the key is there, the software starts. This is a picture from the native Windows, Mac, Linux, Android application. Here, the complete application is encrypted as one block. For .NET, Java, JavaScript, Python, we take the simple or the single message, and we protect every method. And in this case, the method is decrypted automatically during runtime, which already offers a higher level of protection, even if in the usage of the AX Protector without any special handling. For native applications, it is possible to obtain the same security that we automatically have for .NET, Java, JavaScript, and Python by using we call this AX Protector. And here you can define some methods or some functions. And then the AX Protector will first encrypt these methods. And then the AX Protector will encrypt the whole application and, of course, put our security engine, AX engine, at the protected application. And when the software gets started or loaded into the memory, then the application is decrypted, but the single functions which are encrypted stay encrypted in the memory until you use them, which is done in the .NET and Java and JavaScript Python case already automatically. So you need this AX Protector only for native applications where this cannot be done automatically. And with this, you already get a very good and very high level of protection if you do this on the level of single methods. And with code moving, we can go one step further, because with code moving, we can pick functions and move the functions into the the dongle or the cloud container. And so the technology is very similar to the IX protector, where you pick a function and say this function should be encrypted and decrypted dynamically during runtime. And in case of code moving, this is done even better, even more secure.
Yeah, so let's look how this can be done. So as Rüdiger told you, it's kind of the same as IX protector, and the very first part of IX protector is identifying functions which we want to make secure. And in the code moving case, we want to identify functions which are about to be moved inside the dongle. So you have to first step over your program and see if there's a function which can be isolated. And what do I mean with isolated? Yeah, as shown before, the function is executed inside the dongle and it gets input data and produces output data. So all this code of the function should be placed in a separate C file. Why C? Yeah, it's because it's a very generic language. It's so low level that we can easily produce our machine code from it. And you can also organize your functions in separate files for better structuring. Each code moving program consists of an entry function, which has an input struct and an output struct. This is defined by you. So we only give you the signature and you define what input and output looks like. What you also can do inside your code moving algorithm, you can define several sub-functions so you can reuse code and also don't need to put everything inside one function. The downside of putting code inside the dongle is that you don't have any functionality to call operating system API calls. So everything is isolated. It's like a sandbox as shown before, so you can't call find window or anything like that. It's simply not possible. To be able to call the code moving code, you need to put a special WUPI API function into your program. In that case, it's WUPI execute moved code ID, and this instructs the AX engine that you want to call a specific code moving function at that point. And later on, you'll also see how to specify the parameters there. You need also to instruct the AX protector for which ID you want to have a specific code moving function. And this is done as you would specify AX protector. You only now define the respective code moving source file. And also for the newly introduced CPSRT based AX protectors for JavaScript and Python, you modify the YAML file with the needed entries. And one needed entry is the access password, and this needs to be specified in the license. Since you need to have the same access password in the AX protector protected application and the programmed license in the CM dongle or CM cloud container. And as I kind of told you before, it's the same for AX protector in the native AX protector. You simply specify move equals 1 in the source file, and then you have your code moving functionality.
Axel, I have a question here. You say you write here create separate C files. Let's assume I'm a Python developer. I have developed my Python application, and now when I want to use code moving, did I got it right? I need to port the part that I want to execute in the dongle to a C file. Correct?
That is correct. So you can't specify the code moving algorithm in the language you wrote it before. You have to translate it into a C equivalent program, and this is then compiled by the AX protector and later on moved inside the dongle on demand.
Then I got it correct. Thank you.
Great. So now we've covered the part of translating the original program to a code moving equivalent, but you also have to do something with your original application. because this is, I would say, the most important part. Because it doesn't help when you put all the effort in translating the program, but leaving the original algorithm in plain in your original application. So you have to remove it from the application so that no one is able to get it by some mistake. And you also need to encrypt the application with the AX protector, because without encrypting, it's your customer wouldn't be able to execute the program, and also you wouldn't protect any IP. So what does the AX protector do? It compiles all the specified code moving files and encrypts it and stores it inside the appended security section, which Rüdiger told you before. What you also need to do, you need to create a fitting license, and fitting in that case means an identical access password, so that both endpoints can share the same secret. And also we do recommend specific versions for being able to use the latest features in code moving and so on. And the most important thing would be the firmware 4.01, because dongles before don't offer the code moving functionality. And we also recommend the latest CodeMeter runtime in order to be able to use it with CM cloud containers. And also a safe bet is to use the latest protection suite, in that case 11.0, and the latest CodeMeter license central to be able to program the access password and optionally the maximum encryption rate, sorry. So I told you maybe in between the lines a little bit also about the code moving API. And this is also a second part of the code moving infrastructure. And it's there to be able to use, for example, a status slot, which is a 4-byte field, which can be used for state relations. Then we have one memory slot for a code moving program where you can store 246 bytes, which are persistent over several code moving calls. And you have also the possibility to gather specific items from your product item. So without further ado, I would say we come to the meat of our little webinar, and we'll dive into the quick demo.
So Axel has prepared a demonstration program, and we prepared two programs, or Axel prepared two programs for you. One is a Python application, the other one is a native application. And I think let's start with the Python application. And Axel, what type of application do you prepare?
Yeah, I have prepared a little Lotto program where the program predicts 6 out of 49 numbers, which aren't guaranteed the right numbers for the next Lotto drawing, but maybe at some point they could fit. But let's first go over it. We have our Lotto draw function where we put the date inside it. And each draw calls predict 6 from 49. And then we have our magic algorithm. And this does some SHA. It calculates some Fibonacci, does some weird array lookup, filters unique elements, and then sorts the numbers. And we define this is the optimal approach to get the correct numbers for the next Lotto draw. So let's quickly run it to see if it's working correctly.
So what you're running now is the unprotected application.
Right.
So just showing that the application works. And
this is what's doing. So we have our drawing date, which is here, and we have potentially the correct numbers, but without guarantee. I mean, you can place some bets on it, but I wouldn't do it.
But if you start a program again, it has the same numbers, correct?
Right, it's all the same. And as you see in our code, we don't have them statically typed in. We can also change the date, let's say to 2024. And now the first row should be different. And as we see, it's different. So it's really calculating something.
But maybe we go back to the 22 because I could remember the number with the 42 even better.
Yeah. So this is our unprotected program where we define this as our highly secure code. And now, how can we introduce code moving for that program?
I think you need to move this code to a C file and remove it here from the Python file. You create a C file with a port of this part of code, and what do you do that then?
Right, so as you mentioned, we have our C file. In that case, I prepared it, and let's put it side by side. So as I said before, we have our entry function. And then we go here. We have our drawing time. And we have an upper bound, which is the same as the 49 here, because we don't want any numbers above that. We see later on how we can use it for locking the number. But now we have our predict 6 from 49. And this is the same as before from the name. And also we have at first, we have calculate digest, which is this one. Then we have a function init number array, which calls the Fibonacci, and the Fibonacci is here calculated iteratively. Then we have a little function which reduces the range to the limit from 1 to 49. This is the reduced line. Then we have take 6 uniques. So from all the numbers which we calculated, we want to have 6 uniques, and this is the same as this line. And then also we sort the numbers. So this is the equivalent code moving program. And you see this is not only a 3-line program, it has a little bit of IP, I would say. And now also we have to adjust our Python script. And I closed the original one, only to not getting confused. So we have our lotto draw function again, because this hasn't any IP. But now our predict 6 from 49 looks different, because now we have our whoopee execute move code. And here we have our structures input. And we have our output structure. And the input structure has 2 fields, drawing time and limit. And the output structure has fields numbers. And this is an array of 6 bytes.
And I guess in the secure code, we have a function with the name entry, which has the same signature of the function with the input and output parameters, which are defined in the same way.
So as we go before, this was the entry with the in. And if we go above, we have the drawing time, the limit, and the array of 6 bytes.
Okay, and so the input and output needs to be the same from the structure, and the function needs to be called entry. This is the naming convention for this.
The entry is the only function where we can give you the exact name. The rest of the function are up to you how you structure your program does. But this line has to be present in order to be able to be called from outside.
So is it possible now to execute this code without doing the encryption? Testing mode or something like this. Let's
see. First, we make sure that we don't have any license assigned. So our CodeMeter CC looks empty. So now let's go into the modified version and see if it's possible to call it. So our naive approach would be to call Python lotto.py. But now we see module not found our Whoopee engine. And this is because we introduced the Whoopee engine into our Python script, and Python doesn't know anything about it. So what we have to do is we have to introduce the Python installation from Xprotector to the Python path. And I prepared this in our run simulation that bed, and then we can call it. So let's run it.
So this is something like linking the library to a native program.
Right. So it's like the linking directory.
Mm-hmm.
So now we call it, and we see the first time it takes some time, but then the second output is really fast. And why is that? It's because on the first call, we compile the program and produce a library with debug symbols. So this takes some time to compile to a native code. And the second time, this library is reused. So this is because it's a little bit slow on start, but the second time it's fast. So you said if we can run it without license, and I said we put debug symbols in it. The question is, can it then also be debugged? And I prepared a little bit, because this is one of the latest features we provide. I use Visual Studio to debug native code inside a Python application, but you can use any tool which supports native code debugging. And here it's also important to mention, we don't use a Python debugger, because the code moving code is not Python code, it's C code. And what's important that you be able to debug all this code is that you have the starting application as your Python exe. You have your lotto.py as an input parameter for the Python, because this is our script we want to run. And we set our working directory to the folder where the script resides. And also, same as before, we also need to set up the Python path that the Whoopi engine is found. So it's the same as you saw before in the run sim.pad. And now let's see if the program is halting at our breakpoint, which I put here.
So at the end, it is similar like debugging the DLL. I want to debug the DLL. That's why I say this is the executable. It automatically starts the executable. The DLL is loaded, and then you're on the breakpoint of your DLL. That's correct.
Yeah, it's kind of the same principle.
Yeah.
So here we have our program now halting at the entry, and when we look into it, we have our predicted numbers. And as we saw before, our input parameters, drawing time, we have to take it that these are the seconds since 2000. And the limit is 49, as we specified before in our code moving API call. It was here the limit, and here's the drawing time. So we get the right values. Now let's go into the predict function. And now we can step into it as we are used to when debugging native code. So now it takes 6 unique. Let's say we have here our array, which has not unique values at the beginning. Now we go on and we only look at the first 6 values, 5, 29, 3, 7. So these are the 6 unique. Now we sort it and we go also into it, and now we see 3, 5, 7, 24, 29. And now we go on. And now we're holding it again, and this is because we have our second drawing time, but the first one is printed out.
Mm-hmm.
So it's working perfectly. And for the finishing, so you are able to debug your code moving code without calling Xprotector before, and also the possibility to debug it is really helpful for development purposes. And as you saw, you don't need to change any line in your program. You simply run it in Visual Studio or any editor you like, and you are able to develop your code.
For the simulation test mode and this debugging mode, do I need some configuration of CodeMeter, some WBC file, YAML file, something like this?
Right, this is something I didn't show you right now, because
that's why I'm asking.
This is needed to make the link between the lotto.py and the securecode.c. And this is, as I've shown you, the Xprotector Python. It's our CPSRT-based Xprotector with the YAML file. And you specify the YAML file as you are used to for Python applications. But the new section is code moving, where you specify the ID for the function, which is to be linked. And this is the same as we have set in the WIBU execute move code as the first parameter. Then we have our file, in that case, no cache secure code.c, and we have our linked license list. In that case, it's license list 0, and here you see the access password is, in that case, blub.
Very high secure password, Axel.
Yeah, this is the strongest I've ever imagined.
Of course, this is a short demonstration.
Yeah, and now what's also, this is simulation, a simulation type host. And I have also could have removed it, so it would also be simulation type host because it's the default. But you can also switch it to CM dongle. And what does CM dongle mean, you may ask? And this is a mode where we simulate how it's executed inside the dongle. You aren't able to debug this code, but you get some other perks, like we have an execution limit so that we don't execute infinitely inside the dongle. And here you would see when, sorry, when this limit is reached. So it's a different kind of execution. Mainly, if your program runs in host mode, it will also run in CM dongle mode, except if it's a very long one. Then it can be that it's not working there, but you have your simulation and can test it.
You were mentioning that there is an API that you can use. I think you will show it later. But is there a difference between host and CM dongle? Is the API available in both modes or in no modes? How is this?
Yeah, the API is available in both modes.
Okay.
It's only the possibility to debug the application. This is different.
Okay.
And what's also different is that you need for CM dongle a special license from us to be able to use this simulation.
So this simulation is protected additionally by WIBU.
Right. Okay. So now we've talked a lot about not protecting the application, but let's see if it's also running in protected mode.
So this means now you would call AX protector with this YAML file. This will encrypt the application. I think you already did this.
I did this, but I also wrote it down here. It's
Okay.
Python AX-PY prot YAML, and I prepared this already. So we simply call it, and let's see if it's working. The hardest part is to paste it one time. So Python lotto.py, and now it's telling us that license is not available. And as I told you before, I don't have any license in CodeMeter, but I prepared a dongle. So let's quickly connect it into our virtual machine. Now it's there. And now let's run the program. And you see, it's pasting the same output as our unprotected version. So now here we have our 357, and the last one is 42, 357, 42. So it's the same as before.
And what we have seen here, it is now faster than the simulation, because in the simulation, every time when you start the software, it compiles the C file once again. And here now the C file is compiled, is put as a compiled and encrypted blob in your executable. And so we don't need the compiling. That's why it's here faster than during the simulation.
That's correct.
At least in 99.999% of all cases. Maybe there is a...
So now, as we told you that code moving is also available in CM Cloud, we also prepared a little cloud license. I simply drag one inside my CodeMeter CC, and now we call the encrypted application again. And we also see here that it's working as expected. And the difference is now that the code moving program is not transferred into locally connected dongle. It's transferred to our cloud infrastructure. I think it's resided in Frankfurt. There it's executed with the given data, and the data comes back to our machine and is printed out. So I would call this a pretty cool technology.
Could you show us also the protected Python file so that we see that it's now no longer available
Sure.
and clear? I just want to make sure.
So you could say this one looks all plain, but this is all the code from the AX engine, so it's not your code. Your code is at the, or my code in that case, is at the very bottom.
I know what you mean when you say your code, my code.
And here you see all the WUPI interface is stripped out, and the functions are here, and they have all AXE load, and you don't get anything regarded from the intellectual property. And it would be really bad if there would be any code from the C file in plain here or from your Python file, because in the Python we stripped it out. So here you don't have any from the original code, and the code from the C file, you have to trust me that it's encrypted in the AXE data array, and no one is able to decrypt it with a license, because this can only be done inside the dongle. Right. I mentioned before that there's also the possibility to use the code moving is somehow generic for every X protector. So we also prepared a little native application which calls the code moving API. Only need to find the correct folder. Here it is. And we have also the same function, predict 6 from 49. This is a C++ program. We have our WUPI execute move code ID call. We have our input parameters and our output parameters. And let's simply call it in the protected mode. I think I already dropped the code moving license, but let's see. No, it's there, and it prints out the same values.
I remember the 42 at the end, so it looks like the same values.
And as you see, you didn't really see it because I didn't show you. We have here the same code moving file, so you can share one algorithm for any X protector. Now let's quickly cover also a little bit about the code moving API. And this is something we provide inside the code moving application, where you can, for example, fill out data buffers with random data from our more secure random number generator in CM Dongle and CM Cloud. We have our SHA functions, which I have shown you before in the Lotto program. We have also some time functions like seconds since 2000. We have functions to access the state and handle local storage, where you can store values over several code moving API calls. A little handy function is the trap execute call to lock the dongle when you detect malicious behavior. We can retrieve hidden data memory inside the code moving program, and we have also AES encrypt and decrypt calls. Also, we have some convenience functions like memcopy, memmove, memset, etc., because a C programmer is used to that APIs, and so we thought it's a good idea to put them into. So let's quickly see how one can lock a dongle when malicious behavior could be detected. So we prepared something. It's in the log C, and the log C basically checks that the limit is not above the upper bound, and the upper bound is in that case 49, because there's no Lotto entry which is above 49. And if there's a limit specified above that value, then we call trap execute, and we initialize our internal memory to some value which is not correct. But as you see, we don't really call terminate, and also you can see that after execute, these functions are also executed. So you see the code moving program is running from start to finish. You only do this for the next executions. So let's see how this is done in the real world example. And we also modify our script. Let's say we put in 51. And now we protect our application. So it's encrypted. So our application is encrypted again. And I don't want to
lock the cloud license, you want to lock the dongle.
Right. So
at the end, you could do the same, but it's okay.
Yeah, I want to reuse the cloud license right after. So now we protected the application, and we go into the protected folder and execute it. And as you see, the first iteration is not the same as before, because we had 3, 5, 7. This was the wrong tab. And the second one is predicted numbers as an error. And this is exactly what I told you before. The dongle doesn't halt immediately with the execution. It simply sets the firm access counter of 0 and continues. So you can a little bit trick the attacker that a valid call is performing an locking state, but it was an invalid call before. So this is some gimmick we provide, and you should also use in your application. So this was it for the demo, and I think we continue with some roundup.
Yeah. So what have we seen in the presentation so far? We have seen that CodeMeter offers a scalable approach. So you can say, I'm using API calls only. We have not shown this. I think this is quite clear. You can use the automatic encryption of your code using the AX protector. You can use or specify individual functions automatically for .NET, Java, JavaScript, and Python. And in case of native code, you need to specify them. And you can transfer code into a CodeMeter dongle or CodeMeter cloud container to have it on a or execute it in a very secure place. And as Axel showed you, you can trigger the locking of a license if you have some malicious behavior of your software. And so with this means by putting the appropriate effort into the protection, you can reach different protection levels. So you can choose which level you want to get. And our professional services team is ready to assist you. So if you need our help for the implementation of code moving, of course, also for implementation of other features like this individual license protection, license central, and so on, our professional service team is ready to assist you in integrating CodeMeter into your software. Yeah, with this we came to the end of our presentation, and in the chat I saw already a few questions, and I tried to group them a little bit. And Axel, there were some questions about performance. How about the performance influence if I'm using CodeMeter?
Yeah, this is a very often asked question, and I wouldn't put a code moving function inside an audio processing loop or something like that, so where you have real-time needs, because there is quite some overhead to do the code moving. And as I showed you in the example, if the data has to be transferred to a cloud center or something like that, or to the dongle, there's also overhead over the bus or over the internet cable. You can calculate in terms of several milliseconds, but it really depends on the complexity of a program. So if you have a very small program like Return 4, then you only have the latency of your internet connection, basically. So I would say you can get then 40 to 10 milliseconds. But if you have a very complex program, there can be that it takes several hundred milliseconds to finish. So it's up to your complexity of your algorithm, but it's really something you have to be careful about and to really select. I would recommend functions which aren't often called, but contain enough intellectual property that your application needs them to run.
There was also the question about the support of the CM Act license, and I think I can answer the question already immediately because I think I know the answer. Currently, it is not planned to implement this into a CM Act license. This doesn't mean that this is a strictly no-go for all time, but currently this is a technology which is the best security, and the dongle and the cloud container are a real secure anchor. And with the CM Act license, we don't have the same security, and that's why currently it's not planned to implement code moving into the Act license. After the question of the Act license, I have the question with the TMR container, and I think actually this is not possible, and there are good reasons for this. So maybe you can explain if, and in this case, if not, why.
Yeah, so for TMR, I mean, one could think that it works since it uses CM dongles, but since we don't really know on which dongle it's running, and it needs, in the TMR concept, be able to switch over on a failure, we can't offer code moving there because we don't synchronize the states of the dongles between the TMR containers. So it's more or less a server scenario, and for code moving, we don't offer server scenarios with CM dongles, and therefore you are better to switch over to CM cloud containers, where we offer also the code moving protection.
I think there's a very cool feature that Axel did not explain, not show in detail. You have the option to cache some information in the dongle or in the cloud container. So maybe if you execute the same function multiple times and you think, okay, I want to keep the result already in the dongle, then there are some status slots where you can store the information. And in case of a TMR server, you already calculated this, your software thinks, okay, this is the second call of the function, but at the end, the TMR puts it to another dongle, and then the status would not be the same. And so this is one of the reasons that we have this state engine, or the possible state engine, which would not work via TMR, and that's why code moving is not activated in TMR at all.
But this is also brings me to another information, only to round it up. The stored information in the handle local storage and the status slot only survives a standby. On reboot, or if you replug the dongle, this information is cleared, so you don't have it anymore. It's only available during, I would call it, a session.
So after getting error 106 means handle lost, you need to refresh some caches or something again. And the last question was about the size of the code moving block, Axel. Can I put an unlimited size of code in the dongle, or are there some restrictions, and what do they depend on?
Yeah, the restrictions are indeed there. Currently, we support up to 2.5K of code and data, and this is a mixture, so you can decide on your own if you want to have more code or more data, but you can't have both at max. So if you have very few input data, you can use more space for your code and internal data. And if you have lots of input data, let's say 500 byte input data, which is transformed like a custom defined encryption algorithm, for example, or some image processor, then you need to have the same amount of data going out. So you have spent 1K on data, and you have only 1.5K left of code inside the dongle. So this depends on your algorithm, but you can decide on your own how you want to use it.
And we have system limits for dongle and cloud container.
Right.
Okay. I see there are no further questions in the chat, so then I say thank you very much for your attention, and thank you very much for staying with us even longer than the 60 minutes. And hope to see you again in the next webinar. Thank you. Have a nice day. Bye-bye.
Thank you and goodbye also from my side.